Institute of Standard and Technology and published as a Federal Information Processing Standard FIP 180. Sometimes it is referred to as a secure hash standard. Now, the standard is based on a MD5. These are the basic theory concept. The standard was revised in a 1995 under the FIP 181, which includes the SHA1, and it was revised under the FIP 182, which defines a four new version of SHA 224, 256, 384, and 512. These are the different versions of SHA. Right now, these are some characteristic of this or you can say SHA, or you can some of the in some you can also read in that VISA 512, or I can say that SHA 512. Okay, so in this characteristic, I can say that for SHA1, the maximum message size, that is 2 raised to 64 minus 1 in 286. You can sorry 256, it is 2 raised to 64 minus 1, and in SHA 512 it is 2 raised to 128 minus 1. What is the block size? So we are using this, I am talking about only this SHA 512. So what is the block size in SHA 512? It is 1024. The message digest size, that is 512. How many number of rounds are there? Total 80 rounds are there. And what is the word size? And what is the word size? That is 64. Now see here, sorry. Now see this figure here, the block size is 1024, right? The message digest size is 512. Here in between, from this 512 to this 512, when the another digest that you are getting at that time, how many rounds are there? Total 80 rounds are there, right? So how that 80 rounds are there? Everything that I will explain you, so you can understand, right? And the word size, that is 64 bits. Okay, so that you have to remember. So these are the characteristic of SHA. Now in SHA 512, it insists that the length of the original message be less than 2 raised to 128. Listen, each and every topic are linked. If you have any doubt, then please ask me. Right, up to this clear, everyone? Is it clear to you all? Because each and every topic are linked with you. Okay. Is it clear, everyone, up to this? Can you hear me? Okay. See, here I can say that the SHA 512 that insists that the length of the original message be less than 2 raised to 128 bit, right? The message length that is less than 2 raised to 128 bit. So here you can say that the 2 raised to 180 bits is probably larger than the total storage capacity of any system. It is larger than the total storage capacity of any system, right? Now, what is the padding and length field in SHA 512? So now see, all of you know that here in SHA 512, when you see this figure, you can say that the block consists of 1024 bits, means it is a multiple of 1024 bits, right? In this figure. So I can say that what is the padding and length field in SHA 512? So here you can say that the length, that is what all of you know, that the length that is less than 2 raised to 128. And what is the length of the original message? How it is stored here? So whatever the length, see, first of all, the binary is performed, whatever the length is there, and that binary is stored over here. Okay, but it must be a what? Multiple of 1024 bits. Okay, so original plus length plus padding, it must be a multiple of 1024 bits. So the unset integer field of 128 bits can define a number between what? 0 to 2 raised to 128 minus 1, and which is what? Which is the maximum length of the message which is allowed in a SHA 512. Okay, now before the addition of the length field, we need to pad the original message to make the length of to make a length multiple of 1024. Now listen here, when I perform, see, this message plus length plus padding, so the summation right? It must be what? It must be a multiple of 104. That's why I can say that m plus p plus 128 more 1024, that is equals to 0. Okay, so this thing that you have to keep in mind. Okay, now one of the question is, this type of question can also be asked, that is, what is the number of pairing bits if the length of the original message is 2590 bits? Now all of you know this equation. So the message plus padding plus this length more 1024, that is equals to 0. That what is the meaning of it? It must be a multiple of 1024 bits, right? So that means, see here what happened in this equation. If the length of the original message, that is 2590 bits, is given, okay, so now the question is, what is the number of padding bits? How many number of padding bits are required such that you can say that it becomes a multiple of 1024 bits, right? Up to this clear, everyone? Priyank, see, your your message is of some bits, right? Now, what happened? Your message of some of the bits. Now you are adding. Basically, length is what? Whatever the length is there, right? You have to make a binary of it, and it is stored over here. So what happened? Whatever the message plus 128. But see, if message plus 128 is add, okay, whatever the message plus 128. But after that, if it is not a multiple of 1024, then you have to do the padding. Now clear, Priyank? Binary. Now fine. So now see here, here I can say that the message that is 2590 plus 128 plus this padding more 1024, that is equals to 1024, that is equals to 0, right? Now here in this case what happened? This padding that is equals to minus 2718 more 1024. So what you get the padding, that is 354. What is the meaning of it? Now see, when you observe here, the pairing, that means the one below followed by number of zeros. So here what you get 354. That means I can say that the pairing consists of one followed by how many zero? 353 zero. Right. Now if you want to check whether the after adding this pairing, now you are getting the multiple of 1024 bits, that if you want to check. So now what is its value? 2590 plus just wait. Okay, sorry for interrupt. So now see here in this case, what is the message? Message that is 2590 plus 128 plus what is the padding that you are getting? That is 354, right? So what you get the answer? 3072. And see here, it is the multiple of what? It is the multiple of 1024, right? So here it is, the question is, what is the number of padding if the length of the original message is 2590? Here what's the condition? So after the addition, it should be a multiple of 1024 bits, right? So now here the message is given to you 2590 bits, right? This length is 128, right? Plus the padding. So here the padding you are getting, that is 354. So now after the adding, what you are getting? 3072, and it is a multiple of 1024, right? Now it's fine, everyone. Is it clear to you all? Please reply. Okay. Now see, what's the next question? Do we need padding if the length of the original message is already a multiple of 1024 bits? The answer is yes. Why? Now see, here the answer is given to you. This is the PDF from your book. Okay, so I will also share this PDF, and this is my material. Okay, so the question is, do we need padding if the length of the original message is already a multiple of 1024? Now see, the question is yes. Why? Yes, we do, because we need to add the length field. Every time all of you know that the message plus length field is add. So the padding is needed to make a new block a multiple of 1024 bits. Right, and that's why the padding is required. Right. So you can say that if the message is 1024x bits, then how much padding is required? Right. If it's a multiple of this, then how much padding? So here I can write in this way: message plus p plus 128 more 1024, that is equals to 0. This type of question can be asked in exam, right? So here I'm putting this value m, that is 1024x, right? And see, when I'm performing this, so what I'm getting 896. So the answer is the 896 bit padding is required, right? So I think everyone is clear in this concept. Now the example number 3, that is, what is the minimum and maximum number of padding bits that can be added to a message? Just wait, everyone. What is the minimum and maximum number of padding bits that can be added to a message? So here I can say that the length of the minimum padding, that is 0, and the maximum padding, that is 1024. Now what is the first case? So if the message plus 128, if it is a multiple of 1024, it is equals to 1024x, then I can say that the padding is 0, right? This is the first case. And what about the second case? So if the m plus p plus 128 more 1024 equals to 0. So now here I can say that the padding, that is equals to, I can write in this way: minus in bracket minus m minus 128 more 1024, right? The minus is outside, so this more m plus 128 more 1024. Now suppose, let's say the and that is 897 bits, right? So if I'm putting this, so here I'm getting what? Minus 1025, right? And basically it is 1023, right? So here I can say that if my message plus 128, because here it's a 1025, so I can say that if message plus 128, that is equals to 1024 plus 1, then I can say that how much padding is required? 1023 bits padding is required, right? So these are the all two cases, first case and second case, right? Now the most important thing, that is how the message digest creation in SHA 512 is done. So now see, up till now what I have explained you, that is, see, this the how the padding and length field in SHA 512, right? Basically the block is what? The block is a, you can say that the particular block is 1024 bits, right? So now what is that thing, right? How the padding and length field in SHA 512? So that thing that I have discussed. Now the next concept, that is how the message digest creation in SHA 512 is done. So first I will explain you, and based on that each and every concept I will explain you in detail.